Alright guys, so today we're going to be looking at how to find limits, but we're not going to have any diagrams this time. So we were doing limits graphically. Graphically is a little bit easier because you're just looking at a picture, whereas analytically we don't have a picture and we have to still find the limit. I know. So the definition of a limit, here's the kind of explanation of it. If we do have a limit, it's going to be that y value that the function gets closer and closer to as x gets closer and closer to some certain x value. And it has to be true from both the left and the right. So the reason why it isn't too difficult to find this limit is because this is a continuous function. What would you think we would do to find that y value if we have a continuous function? Plug it in, yeah, just plug in the number. So if I plug 3 into here, I get 11. So that's the answer to this limit. We don't have to have a diagram to find the limit. All we have to do is substitute in the value. This is called direct substitution. What is the y value that this is approaching as x approaches 3? We don't necessarily have to be equal to 3, but in this case we are. So many functions are continuous, meaning that there are no gaps or holes in the function. For these functions, we simply plug in the x value. That's what we mean by direct substitution. So what we could say then is, for continuous functions, the limit of f of x as x approaches c is just f of c. But if the function is not continuous, then it may be the case that the limit does not exist. But not necessarily. So we're going to have some cases where the limit does not exist, but other cases where it does exist even though the function is not continuous. Alright, so on this, is this a continuous function? Y equals 3x plus 2? Yeah, it's just a line, right? So all we have to do to evaluate is plug in -2. So we're going to do 3 times -2 plus 2. -6 plus 2 is -4. Looking at the next one, is y equals x squared plus 4 continuous? What do you think? Is it? What kind of shape is it? Parabola. So we can just plug in -1. So -1 squared plus 4. That's going to be 5. Is the sine curve, are sine curves going to be continuous? Yeah, so I can just plug it in. The sine of pi over 6. Plugging in pi for x. What is that? It's a 30-degree reference. What is the sine of 30 degrees? 1/2. All right. Down here, cosine curve. Is the cosine curve continuous? Yep, plug in 0. Do you know the cosine of 0? It's 1, isn't it? Is the tangent curve continuous? No. But guys, here's what the tangent curve normally looks like. It's going to be going up like this, and it has vertical asymptotes at pi over 2, negative pi over 2, all those multiples of pi over 2. This one would not have vertical asymptotes at that same place because we would have actually a horizontal shrink. But the first thing we always try to do is just plug in. So I'm going to try to plug in 2 for x. We would still have an answer for this, right? We can evaluate the tangent of 2 pi over 3. Pi over 3 is 60 degrees times 2 is 120. So I'd have a 60-degree reference. That would be the way my triangle would look to figure this out. Tangent's opposite over adjacent, and so it's negative radical 3. All right. Cotangent. Is cotangent continuous? Nope. Where does it have vertical asymptotes? Remember that trick I told you? Cotangent has its first asymptote at 0. So it has an asymptote at 0. asymptote at pi, asymptote at negative pi. So as we approach 0, this is the way the function looks. As I approach 0 from the left and the right, am I approaching the same value? No. This would be where the limit does not exist. Now another way of evaluating this would be just to go to 0 on the unit circle. This point is 1, 0. Cotangent is going to be x over y. What do we get if we do 1 divided by 0? Undefined. But that does not mean the limit's undefined. That means the limit does not exist because we got an undefined value. It's, you know, kind of tick-tacky it feels like, but limits are always, you know, you can't say a limit's undefined. You have to say does not exist. All right, the limit of a composite function. If f and g are continuous functions such that the limit of g of x as x approaches c is L, and the limit of f of x, that was g of x, of f of x as x approaches c is L, then we can say that this limit is going to be this. Now, this is a very complicated way of looking at it. That's what makes college difficult as a college calculus difficult, is because, you know, they'll give you something like this that looks so complex, but this is actually very simple. All it means is to plug this c value into the inside function, get that answer, and then plug that answer into the f function. It's exactly what you think you should do. If you're ever in college calculus and you don't know what to do, just do something that seems reasonable, and most of the time you're going to be right. Okay? So on this problem, this is an easy one. We're just going to plug 3 into the f function, and we get 10. This one looks complicated, but what do you think you should do? Plug the 3 into which function first? F. What do we get for that? 10. And now we plug that 10 into the g function. So our answer then is going to be just 10 squared, which is 100. See how that's very intuitive? It's just what it seems like you should do, and that is the correct method. All right, what about on this one, though? Where are we going to plug the 3 in first? G function. So plug it in for g. 3 squared is 9. And now plug that value. So now we have f of 9. So plug that in, and what's our final answer going to be? 16. All right, so you guys try these last 3 on your own. See if you can get them. One of the hardest things about limits is trying to tell whether it's negative or positive on the value you're approaching. All right, so what about this one? Anybody think they know what this one's going to be? Rachel? 25. Do we agree with 25? That's right. Okay, what about number 5? Anybody have that one? Jamie? 11. So we plug 2 into G, and 2 squared is 4. Yep. And then what about this one? What do you have, Gina? 49. Plug 0 into F, and you get 7. 7 squared, 49. Very good. All right, let's go over to the back. This is a review on how to graph piecewise functions. What this would be saying is to graph x squared, but only graph it if x is less than or equal to 3. Then graph x plus 1, but only when x is greater than 3. To do this without a graphing calculator, all I have to do is visualize this function, y equals x squared. That's a parabola. I like to go ahead and plug in 3, and I get 9. So I'm going to have a closed dot at 9. I'll plug in 0. 0 squared is 0. I'll plug in negative 3. Negative 3 squared is 9. So this function goes on forever in this direction, but it actually has to stop right there. And that's because it says we're only graphing this if x is less than or equal to 3. I'm going to go ahead and plug 3 in here. 3 plus 1 is 4. So when x is 3, I get 4, but I have to use an open dot here. Then I have to graph the line y equals x plus 1. That's just a line with a slope of 1. And so it's going to go up like that. That's the way that's going to look. It's really nice to also be able to graph these on the calculator. Just to remind you how that's done. You don't have to do this yourself, but just watch. To do this, I would just put in parentheses x squared. And then I have to tell it what to do with this. So then I'm going to have to put in another parenthesis and give it a restriction. So I'm going to have to say x has to be less than or equal to 3. That less than or equal to can be found under test. You guys go ahead and try to do the problem down there, that wrap up, write any limit such that the answer is 8. See if you can do that on your own. All right, so back to here. So what I have to do then is I have to say graph x, and then I have to go under test. Test is right here, so I go second math to get to test. And I can tell the calculator to only graph this when x is less than or equal to 3. Then I go down here and I put in x plus 1, but I tell it in parentheses, only graph this when x is, go under test. Have you guys seen this before or not? Yep. Greater than 3. And then I can do my zoom 6. And so now it should only graph that parabola. Yep. And there it is. And I have some other random things in y equals, but there we go. All right. So did anybody get this? Write a limit problem such that the answer is 8. Did anybody come up with one? What did you get, Claudia?
I said the one that x approaches 3 is 2x.
That'll work, won't it? If you plug in 3, you're going to get that. You may have another one, different? What do you think, Rachel?
The limit as x approaches 2 of 2x squared.
Yep, that works. Very good. All right, so you can see that we could write any of these problems so that we get an answer of 8. All right, so that's it. You guys have some problems to do in the book. It's page 65, 5 through 35, and I have the link on Canvas for you.